Hello and welcome. We are still on transformations. This is the last transformation of the series, and this transformation is called dilations. So dilations is when you take an object and shrink or stretch it. So stretching it, making it bigger, or shrinking it down, making it smaller. It will still be the same shape, but no longer the same size necessarily. So we don't have the congruent shapes. Instead, what we have are similar shapes in the end. Sometimes we'll get congruent shapes, and I will show you when that will happen. But for the most part, we should think of dilations as similar figures, not congruent figures. All right, so I've already got a problem up. We've got point A, which is at -1, 1. We've got point C, which is at 2, 1. And point B, which is at 2, -3. The instructions here are for us to dilate about the origin by a factor of 4. Okay, so again, we're going to focus our attention on dilating about the origin, because just like in rotations, you can shift your point that you're going to do your dilation about, and then just dilate about the origin. So really you can save yourself a lot of time just focusing your attention on how to dilate about the origin. All right, so we're dilating about 0, 0 by a factor of 4, and if you want, you could write down the rule. Unfortunately, you can do a factor of any number, so the rules, there would be an infinite number of rules if you want to write them all down. So we want to come up with a general rule. So if we are dilating by a factor of A, where A is greater than 1, we're going to write down a rule here. All points, point P, x comma y, become point P prime, ax comma ay, and the shape stretches. It means it gets bigger. So there we go. That's definitely a rule that we can put in our notes. If you like the algebraic thought process here, this rule is really helpful. It really helps you with any dilation of a number greater than 1. So that really kind of helps out, I think. All right, so let's go ahead and see what happens here. We're going to take -1, 1, and we're going to multiply each of those numbers by 4. So if you want, you could write down a -1, 1 becomes a prime. -1 times 4 is -4, and 1 times 4 is 4. So -4, 4. And we get a prime at -4, 4. Okay, and then we can go to B. You do not have to write these rules down like this for each problem. That would be time consuming, and I'm not saying you need to do that. This is just a visual for you to kind of understand what we're doing here. If you want to just multiply each number by 4 and put that new number down, that is totally fine. You don't have to write this. But if this helps, you certainly should write it down if it helps you out. Okay. All right, 2 times 4 is 8, and -3 times 4 is negative 12. Alright, so we've got 8 comma negative 12. Hopefully I can go that far down. 3, 4, 5, 6, 7, 8. 7, 8, 9, 10, 11. No problem. So we're going over 8 and then down 12 to get E prime. Notice I'm not writing the point next to it, and that's because I've written it over here. If I didn't do this side work, I'd need to write the new point down over here. You always want to write down your new point so that when I'm looking at it, I can tell that you, even if you made a little bit of an error moving it over, I could tell what point you meant to put it at, and maybe you just moved it one less. I wouldn't take any points off then. So it's a way to make sure you get full points. So make sure you write down your points that you're getting. All right, C prime. So C was 2 comma 1. And so C prime will be 2 times 4 is 8. And 1 times 4 is 4. And there you go. 8 comma 4. Well, we already went right 8 for B prime, so we've got that, and then up 4 for A prime, so we've already got that point, so we can just go right here. C prime. And there we go. We have officially stretched our shape out by a factor of 4. All right, so here is our new problem. We are dilating about the origin by a factor of 1/3. Dilating by 1/3. 1/3 is greater than 0, and 1/3 is less than 1. So we're between 0 and 1. It will actually shrink our object. So our object's actually going to get a lot smaller than it already is. So let's just start with A. A was 0 comma 9. And it becomes A prime. 0 times 1/3 is still 0. And then 9 times 1/3. Well, 9 times 1/3 is the same as 9 divided by 3. And 9 divided by 3 is 3. So our new point is 0 comma 3. So here is A prime, 0 comma 3. Notice that the x value stayed 0. And that's because we were on the axis. Whenever you're on the axis, you'll stay on the axis. If you're dilating about 0, 0, you'll always stay on the axis because it makes a straight line from 0, 0 through the y-axis and through the x-axis. So since our x value was 0, we just stay on the y-axis. All right, B. B is 3 negative 3, and it becomes B prime. 3 times 1/3, or 3 divided by 3, is 1. And then negative 3 divided by 3 is negative 1. So we get 1, negative 1. And there's B prime. C prime, negative 3, negative 3, multiplied by 1/3, or divide by 3, we're going to get C prime is negative 1, negative 1. And there's our end solution. Pretty nice. So I just shrunk it down. These are similar shapes. They are the same shape, but they are not the same size. They are what we would call proportional. So there's some proportions going on. If you think about it, side AC divided by side CB is congruent to or equal to side AC divided by side CB. That is proportional. So we will get into proportions later But dilations really are where we're going to see our proportional rules coming out and shining. So, all right, so we need to come up with a rule. We know that it's shrinking, but let's go ahead and keep using blue. We've got point P, x comma y becomes P prime, and that is ax comma ay. We were still just multiplying. We're still just multiplying, so that's fine. All right, and the shape shrinks. We get a shrink. Oh. All right, here is our next problem. We are dilating about the origin by a factor of 1. So when you dilate by a factor of 1, we get a, which is 3, 3, becomes a prime, which is 3 times 1, which is 3, and then 3 times 1, which is 3. It didn't change, so a prime is a. There's no change. Okay? B, 3, 1. Multiplying 3 times 1, you get 3, and 1 times 1, you get 1. So no change. C, which is 1, 1, becomes C prime, which is 1, 1. Because when you multiply 1 times 1, you get 1. And then D, same thing, 1, 3. 1 times 1 is 1, and 3 times 1 is 3. So no change in any of these. A prime is A, B prime is B, C prime is C, and D prime is D. So no change. So we could write this rule down. It's kind of a boring rule, but it's true. So when A equals 1, P of x comma y becomes P prime x comma y. And you might say, well, we could still say A because we were multiplying by A, and you're right. We don't have to write it that way. We could write it this way. AX comma AY, and no change. Well, that's just the symbol for change. So no change at all. I know it's also the symbol for triangle, but it's also the symbol for no change. So nothing changed. It didn't stretch, it didn't shrink, it just stayed the same. So when A is 1, no change at all. Alright, so here's our next problem. We have here point A, which is at 2 comma negative 2, point B, which is at 3 comma negative 5, and C, which is at point 1 comma negative 3. We are dilating about the origin by a factor of 0. Factor of 0. And so you say, well, maybe this isn't possible. And so some people will say, yeah, it's possible, and others will say it's not. I say, let's go ahead and try it. So A, which is 2 comma negative 2, becomes A prime, which is 2 times 0. 2 times 0 is 0. And negative 2 times 0 is 0. B, which happens to be 3 comma negative 5, becomes B prime, which is 3 times 0, negative 5 times 0. And then the last is C, which is 1 comma negative 3, which becomes C prime, 1 times 0, and negative 3 times 0. They all became 0, so we shrunk down to nothing. So A prime, B prime, and C prime are all at 0, 0. So you know, it's another kind of boring one, kind of like when you shrink or stretch by a factor of 1, nothing happens. In this case, everything goes to 0 and shrinks to nothing. So it's kind of silly, but we can still write it. So when a is 0, we shrink. P of xy, it does become P of ax comma ay, just like all of them. But we could simply say it becomes P of 0, 0. Just like in this one, we could say P prime becomes, that's P prime. P prime becomes x comma y. It doesn't change, right? So we could say that. So it is a shrink, but it's a shrink down to nothing. So that's pretty tiny. We're going to do two different things. We're going to do two at the same time. So we're going to actually do a factor of -1/2, and we'll also do a factor of -2 to the same shape, just to see what's happening when a is less than 0 but greater than -1. So a is less than 0 but greater than -1. Okay, so that's going to be another rule. So we're going to have a rule here, and then we're going to also do by a factor of -2. So that's when a is less than -2. Oh, I switched these around. That's why it looks so weird to me. There we go. A is less than 0, but greater than -1. There we go. And then here, A is less than -2. All right. So let's go ahead and just do the -1/2 first. So we're going to have A 3, 5. So A 3, 5 becomes A prime, and we're going to multiply by -1/2. So 3 times -1/2, or 3 divided by 2, is 3/2. So it's going to be a negative though, because we're multiplying by a negative, -3/2. And then 5 times a -1/2 is a -5/2. And we can graph these points. So -3/2, well, -1 is the same as -2/2, and then 2 over would be -4/2. So we're between 2/2 and 4/2 lives 3/2. So we're right in between, and then we're down 1, 2, 3. So 2/2, 4/2, 6/2. 4 and 6/2. Between 4 and 6/2 is 5/2. So we're right in between there. And so there we go. There is a prime. Okay. Then we've got B, which is 5, 2. And it becomes B prime. 5 times -1/2 is -5/2. And 2 times -1/2 is just -1. So that's a nice number. So B, we're going left 5/2 and then down 1. So there's B prime. And then C prime. C is 3, 1, and it becomes C prime. 3 times -1/2 is -3/2, and then 1 times -1/2 is -1/2. So we're going left 3/2 and then down 1/2. And there is C prime. Wow. Okay. A little better. Okay, so what happened here, now it looks like it flipped. It's almost like a rotation, and it really is. It's very similar to a rotation. Had we done by a factor of -1, it would have been the same as rotating by 180 degrees. So that's interesting. So we rotated it and then shrunk it down this way. And so it is a shrink, but also let's see here, P of xy, it becomes P prime ax comma ay, where x and y become negatives, or they change sign. So the x changes sign and the y changes sign, and the shape does shrink. These two shapes are still considered similar. They are similar because they are proportional. They are the same shape, different size. They have a different orientation as well, in the sense that if you think about going from the side BC up to A, we're pointing that way. From the side BC, B prime, C prime, we're pointing this way for A prime. So pointing kind of down the left. This is a rotation in essence. So there's a rotation going on there of 180 degrees. All right. So that's a shrink for when A is less than 0. So it's a negative number that's more than -1. So it's between 0 and -1. Okay. It's less than 0 but greater than -1. All right. And now if we're less than -2, then we'd be less than or equal to -2. I should have said less than -1 here. So -2 is less than -1. And so A is -2. And we're doing the -2 now. We can ignore this. Alright, so 3 times -2 is -6. Let's get our A prime in there though. And 5 times -2 is -10. So there is A prime. B, which was 5, 2, became B prime, which is 5 times -2, which is -10, and 2 times -2, which is -4. So we get -10, -4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and -4. Prime. And then C is 3, 1, which becomes C prime. 3 times -2 is -6, and 1 times -2 is -2. So -6, 1, 2, 3, 4, 5, 6, and then down 2. C prime. Wow, that was a bad line. So you can see it's pointing down and to the right. Here it was pointing up and to the left. So it's still that kind of rotation of 180 degrees. But the real interesting thing is that it grew. It grew. So a factor greater than or less than -1, which -2 is less than -1, actually does grow your shape. Okay? So this is a stretch, and of course Px comma y becomes P prime Ax comma Ay, and it is a stretch because it did grow. So the rules are kind of interesting here, but I think our focus here should be on the fact that we can dilate any shape about the origin by any factor that you're given. There's not a limit to which number you're given. So you can be given a number 0, 1, anything between 0 and 1, anything bigger than 1, and then anything between 0 and 1 that's negative, between 0 and negative 1, and then anything even more negative than negative 1. Of course, if we had done negative 1 itself, a equals negative 1, all the numbers would have just flipped across, so we would have gotten negative 3, negative 1 for point C prime. B prime is 5, 2, so it would become negative 3, 4, 5, negative 2, negative 3, whoops, negative 5, negative 2 for B prime, and then 3, 5 would have become negative 3, negative 5 for A prime. So our end answer would have looked like that. And these would be actually congruent shapes. They're the same size, the same shape. They just have a different orientation, so there would be no change. No change. Alright, so I think we've covered every number. If we wanted to dilate about a number not the origin, a point not the origin, we would just do the exact same thing we did with rotations, and that is move everything over. Alright, last problem. So if we wanted to dilate about the point 2 comma negative 3, so that's what we're dilating about, by a factor of 2, we would just have to convert all of our points into a reasonable number. So we're going over 2, down 3, so we need to subtract 2 from each of our x's, and then add 3 to each of our y's to get the xy to shift over to here. Okay, so this is going to be our new x, and this will be our new y, so that we can have this be our origin. We're going to need to subtract 2 and add 3. So we're going to subtract 2 from 5 to get 3, and add 3 to 5 to get negative 2. We're going to subtract 2 from 3 to get 1, and add 3 to 2 to get 5. And then the last one, we're going to subtract 2 from negative 1 to get negative 3, and then we're going to add 3 to 1 to get 4. And this should make sense. Let's see if it does. So this is our new 0, 0. So if we go right 1, 2, 3, down 2, right 3, down 2. Here we're going to go right 1 and up 1, 2, 3, 4, 5. 1 comma 5. Here we're going to go left 1, 2, 3, and up 1, 2, 3, 4, negative 3, 4. So there's our new values for each of our points. And so now we can do our dilation times 2. So we're going to do 3 times 2 is 6. So this is our new prime number. Oh, I want it green. We want a different color here. Thank you. Alright, so our prime, we're going to do 3 times 2 is 6, and negative 2 times 2 is negative 4. And our new prime will be 1 times 2 is 2, and 5 times 2 is 10. And then our new prime here will be negative 6, and 4 times 2 is 8. Okay, but then we have to shift it back. So we subtracted 3 and added, subtracted 2 and added 3. So now we need to add 2 and subtract 3 to get back to our original origin. So we're going to add 2 and subtract 3. So add 2 to x, subtract 3 from y. And here is, so if this was A, B, and C, our new A prime will be add 2 to 2 to get 4. So this, and then 10 minus 3 is 7. So 4, 7 from 0, 0, from the true 0, 0. Okay? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And here is our true A prime, 4, 7. Our true B prime will be 6 plus 2 is 8. Negative 4 minus 3 is negative 7. So 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So write 8 down to 7. So this is our true B prime. And then our C prime, we're going to take negative 6 plus 2 is negative 4. And 8 minus 3 is 5. Negative 1, 2, 3, 4. Up 5. 1, 2, 3, 4, 5. Over 4. And that is our true C prime. And there we go. And that is our stretch by a factor of 2 about the point 2 comma negative 3. So we were stretching about this point, not this point. So we had to do some work to get it into points that we could use, and then we were able to then figure out what those points were. So first we converted, then we multiplied by 2, and then we had to convert back. So we did this step first. We subtracted 2 and added 3 to each point. And then we multiplied by 2. And then we added 2 and subtracted 3 from each point. And that got us the correct answer. But I'm not planning on having us focus on doing dilations about points other than 0, 0. I just wanted you to see that it is possible. And we may have a challenge problem where I give you a problem like this. And if you want to practice it yourself, you're certainly welcome to do so. And you can make up your own problems. These are pretty easy to make up. Triangles are great because there's only 3 points to deal with. So I would recommend doing lots of triangles for your practice if you want to make up your own problems. Alright, that's about it for me. If you have any questions or concerns, feel free to Canvas message me. You can email me. I will be available. So just let me know if you need any help. Be sure you're working in partners and study groups. Get each other's phone numbers. And good luck. Alright, have a good day.